Assalamualaikum and hi. So today, our group gonna present about control system for car suspension. So in our group has four members. We are from 2BMID section 1/1. The first member is Jasmeen Sabrina. The second one is me, AZRUL. The third one is ALYA NABIHAH, and the fourth one SETH AQLAN. Okay, the introduction. Second order system are widely used in many engineering applications because of the precise modeling of dynamic behavior differential equation of the system, contains term proportional to the second derivative of variable like position, velocity, or acceleration. Because they describe a broad range of physical system, from electrical circuit to mechanical oscillator, they are essentially to control engineering. So, the explanation. Second order system are used in engineering to control and model dynamic system for this system to carry out the intent function precisely and efficiently. Control systems are necessary. Control can be used to optimize, stabilize, or regulate the behavior of a system. Example include controlling an aircraft flight path, regulating a motor speed, and maintaining a room temperature. Daily life application has three. The first one is temperature control. To maintain a desired temperature, thermostat in heating, ventilation, and air conditioning HVAC system are utilized control system. The second one is automotive cruise control. By varying the throttle position, control system enable vehicle to maintain a predetermined speed. The third one is home appliances. Control system are used by the refrigerator and washing machine to maximize energy efficiency and performance. Application in car suspension system. In engineering, car suspension system are prime example of second order system. They are made to control the dynamic interaction between the car body and wheels in order to absorb shock from the road and offer a comfortable ride. Component of car suspension has four. The first one is spring, store and release energy to absorb shock. The second one is damper or shock absorber, dissipate energy to control oscillation and stabilize the vehicle. The third one is control arms. Connect the suspension to the vehicle frame and allow for control movement. The last one is anti-roll bar to reduce body roll during cornering.
Hello, I'm Asri. This page shown control in car suspension system. Car suspension system use control to improve comfort, safety, and performance. Modern suspension system like active and semi-active suspension employ control algorithm to instantly modify the damping force according to the driving situation. Okay, read type of suspension control. First one, passive suspension, release on fixed mechanical properties of spring and dampers. No external control is applied. Second is semi-active suspension. Adjust damper setting in real time using control algorithm. The system use sensor to monitor road condition and vehicle dynamics, adjusting the damping force accordingly. Okay, the last one, active suspension. Use actuator to apply force to the suspension system actively. The system can change the position of suspension component in real time, providing the highest level of control and ride comfort. Control strategies in car suspension have three types. First one, PID control, proportional integral derivative. Commonly used in semi-active and active suspension system, PID controllers adjust to the suspension parameters to minimize the error between desired and actual performance. The second is skyhook control, a specific control strategy uh, used in semi-active suspension that aims to simulate a damping effect as if the car body is suspended from the sky. The last one, model predictive control (MPC), an advanced control method that use a model of the vehicle dynamic to predict future state and optimize control action accordingly. Okay, is it stability of a system? The capacity of a system to regain equilibrium following a disturbance is referred to as stability. Stability in second-order system is an important consideration. When a vehicle encounters a bump or the irregularity in the road, a stable suspension system makes sure that it does so without experiencing excessive oscillation or long cycle time. Control systems play a critical role in stability maintenance by dynamically modifying the suspension response to guarantee safe and efficient operation.
Hello, my name is Nur Alia Nabihah binti Mama Yaakob and my metric number is B0922104191, and today I'm going to present the data analysis. For the first thing is, we will see the block diagram where there is a summing junction that is connected with controller and also system, and there's also feedback in the block diagram. And for the controller value, we put it as 30, and for system is 1 over 2s squared plus 10s plus 25, and for the feedback value is 1. Next, we will go to calculation. For the calculation, we have to find the value of transfer function. First of all, we have to settle down the series problem where there's a controller and also a system. Then we got the value is 30 over 2s squared plus 10s plus 25. Next, we have to find the value for the feedback, which is we got the value is 30 over 2s squared plus 10s plus 55. Okay, for the next calculation, we have to find the value of settling time, percent overshoot, and also peak time. And for the first step, we have to find the value of omega n and also the value of zeta, where we got the value of omega n is 5.477 and for the zeta is 0.913. Therefore, we will find the value of settling time, and we got the value of settling time is 0.8, and for the percent overshoot is 0.088%, and for the peak time is 1.446.
My name is SABRINA binti Muhammad Jusri. I will be continue to present on the MATLAB section. We use MATLAB to determine the output response of the car suspension system. Since it is a second order system, here are the code that we come up with to generate the peak time, settling time, and percentage overshoot via MATLAB calculations. We can see from the command window that the transfer function and k value has been simplified into 30 over 2s squared plus 10s plus 55. This function is tallied to the manual calculation of the unity feedback mechanism system. The graph outcome shows that the peak time is at 0.682, settling time is at 1.57 seconds, and percentage overshoot is at 18.20%. Comparing the value that we derive from both manual calculations and MATLAB calculation, there is a large significant difference in both data. This can be explained as MATLAB employs the floating point value, which may result in minor variations in result. Other than that, since the step response is calculated at predetermined time intervals, this discretization might result in disparities in response compared to continuous time system, which calculate direction at any point in time. Below are the calculation for the steady state error for step input, ramp input, and parabolic input. Step input we derived is 0.6471, meanwhile both the ramp input and the parabolic input is at infinity. Based on our findings, we can conclude that the system is unstable as it is a type 0 system. According to calculation, the system has a Kp of 1.545, indicating the system cannot accept a unit ramp input or a unit parabolic input without having infinite steady state error. Based on the findings, the system is not stable as it is a type 0 system. This is because the steady state error for a unit system input is non-zero, indicating that the system cannot accurately track the input signal without any residual error. This is because the system does not have any integrators, meaning that it cannot eliminate the steady state error for step inputs. Thus, the system cannot achieve zero steady-state error for step as the finite k is non-zero, making it unstable in this sense.
Okay, as a conclusion, second order systems are integral to engineering, providing essential insight into dynamic behavior and control mechanism. Car suspension system, as a practical application, benefit greatly from this principle, ensuring enhanced ride comfort, safety, and performance. Manual calculation aided by tools like MATLAB enable precise design and optimization, minimizing steady-state error and ensuring system stability are paramount in delivering a superior and reliable driving experience. Through careful analysis and advanced control strategies, second order system continue to drive innovation and excellence in engineering application. That's all from us. Thank you.